In this video, I'll present two examples of multiplying complex numbers. The first will be to find the product of 2 plus 3i and 4 plus 5i. As I perform this multiplication, I will treat I as I would treat a variable. Although I is not a variable, I is a representation of the square root of -1, but I can treat it as a variable as I do this multiplication except for one situation. If, and this will happen, after multiplying I end up with I squared at any point, remember that I squared is equal to -1. Let's begin this first example. When you multiply two binomials, you can begin by multiplying the first terms, 2 times 4, which has a product of 8, and then I'll multiply 2 times 5i. Treating I like I would treat a variable, 2 times 5i has a product of 10i. Then I'll take 3i times 4 and find that to be 12i. And finally, the product 3i and 5i is 15i to the second power. Now, the two middle terms, 10i and 12i, you can think of these as you would think of like terms. 10i plus 12i is 22i. And then the last term, 15i squared, this involves an I to the second power, so I have to replace that I to the second power with -1. I to the second power is actually a real number, -1. So 15 times -1 is -15. So I end up with 8 plus 22i plus -15. And then adding 8 and -15, I get -7. So the answer to this problem, the product of 2 plus 3i and 4 plus 5i, is -7 plus 22i. When writing complex numbers, you should write the constant first, the real number part first, and then add or subtract to that the imaginary part. This product is best represented as -7 plus 22i. Let's look at one more. 7 minus 4i squared. Now 7 minus 4i squared is the same thing as 7 minus 4i times 7 minus 4i. And if I write it like that, I can perform this multiplication using basically the same process that I used in the previous example. I'll begin by multiplying 7 and 7 to get 49. Then 7 times -4i is -28i. -4i times 7 is again -28i. And the last multiplication that I'll do is -4i times -4i, which is positive 16. I times I is I squared. At this point, I'll combine -28i and -28i to get -56i, and then I will replace I squared with -1. I will replace I squared with -1. So this becomes 49 minus 56i plus -16. And the final step in the problem is to add 49 and -16. And I'll write that as the first term in my answer, 33 minus 56i. 7 minus 4i, quantity to the second power, simplifies to 33 minus 56i.